Good afternoon. Okay, so let me start out by making a few clarifying remarks about the midterm, and if you have questions, please do ask. So a couple of questions came up, which is, I didn't go over in lecture any of the material on bits and bit operations. There will not be any of that on the midterm or in the course in general. I'm skipping those. I think there's 3 lectures on that material. Okay, so we sort of jumped in lectures from like lecture 13 to lecture 17 or something like that. I'm skipping that material entirely. It's wonderful material. If you're bored, go ahead and take a look at it. It's pretty interesting stuff, but will not be relevant for Pick 10B, this class, this quarter. Everything up to and including lists, queues, stacks, but not sets will be fair game for the exam. So everything up till last lecture until that part where I went from talking about queues and stacks to when I switched to a new set of slides and started going over what sets are and all that. There won't be any material of sets on the midterm. But everything that came before that, yes, it's all fair game. Okay? Any questions? Yeah? It has a high probability of being a similar style as to previous exams. Yeah. I can switch the style up as I please, but in general, I like to see you guys demonstrate your abilities and your knowledge, and I prefer not to test your ability to just all of a sudden, get exposed to something very unfamiliar, and I'd rather give you this scenario where you can demonstrate your mastery of the material, but sometimes I do like to throw in problems where it's of a different form than you will have seen before to make sure you understand the concepts. But my every intention is to make the exam more or less a similar format as before. Any other questions? Yeah. In general, yeah, it's always cumulative, especially for programming, right? Because I might have you guys make a class and then say write a class without any memory leaks that does such and such. And even though memory leaks was something that was covered on the first midterm, I think, right? So even though that was more or less a more focus on the first midterm, it is definitely a concept that would carry over into the second midterm, and you just can't regress back to, I would still expect you guys to maintain that standard. So memory management is a big one. That's definitely one that I would expect you, cumulatively speaking, yes, do not write code that knowingly has memory leaks in it, because now you know the proper way of handling memory management. Any other questions? Yeah.
On the test, will you expect us to be familiar with all the helper classes we've used? Like, for example, if you want to find using a string, that we know the subster, the method name and things like that. So should we know all those that you've used in the past?
In general, so the question is about which member functions of, say, vector or the string libraries I would expect you to know. Basically, if I used it in lecture, I would expect you to have it memorized and know how to use it. If I did not use it in lecture, what I usually do is if I want you to use it or if I expect you need to use it, I will provide a page of documentation from, say, C++.com in that style so that even if you don't know it off the top of your head, you should still be able to intelligently read a source which demonstrates what that function is and then properly utilize it on the exam. So I don't value memorization, in other words. Okay? Something as simple as subster, which I use several times in lecture, yeah, I'd kind of expect you to know that one. Vector, v.size, yeah, that one you should all have memorized by now. But maybe some of the more obscure ones or whatever, when you're coding, as soon as you write now v dot, a whole nice long list of possible member functions comes up that you can call. If you don't remember what one does, you can go to a documentation online like that. So the emphasis I try to place on exams is not on memorization, but on utilization. In other words, using the tools which I expect to be floating around in your memory, what can you create? Or if they're not floating around in your memory, or I wouldn't expect them to be, can you quickly disseminate some very standard looking documentation and then implement the code from there? That's the general idea. Yeah. I'm not big on I'm not big on memorizing implementation details of classes. Understanding, for example, the difference between a linked list and a vector. That's something you have to just know. How memory is stored. But some of those other subtle things about the implementations are not so important. Yeah. Anything else? Okay, if you have questions before the end of class today, please do feel free to ask at the end. Okay, so today let's start off where we left off last time, which is on sets and multisets. And in particular, I'm going to show you how in the code, what you can do is you can do what's called setting policy. That's a term you don't really need to know at the moment. But what you can do is you can store collections of objects, and you can specify how you want them to be stored, the particular manner in which you want them to be stored. Okay, so let's demonstrate what let me explain further what I mean by that very shortly. So let's just recall last time, what is a set? So that's describing a multiset up there. A set is an unordered collection of distinct objects. Okay, so with integers, if you have like the numbers 1, 3, 5, 5, and 7, the two 5s don't matter. It's just there's a 5. Doesn't matter how many times you want to think about it, 5 is in the set. A multiset is where, again, the order doesn't matter still, but the number of times an element occurs does matter. We do want to know, for example, here that there are two 7s. Because, for example, in your homework on recursion, there's an object called the integer partition. And there, the size of the partition is the sum of all of the components. And so, yes, the number of times the number 1 appears does have an impact. We do need to know that information. Okay, so the multiset is actually implemented really nicely in the standard library in C++. You just take all the stuff from the set library, all of those operations, pretty much is all the same, and you add in another member function called count with a parameter. And all it does is tells you the number of times that the element could be in the set. So actually, set has this, but count just returns a 0 or a 1. With a multiset, calling count could return any non-negative integer. Okay, now let's just recall set. Okay, so we have a set here, and remember I C++ 11ified outputting the elements of that set. Okay, so again, the standard way to do it would have been to use iterators, a set of ints iterator. And writing this gobbledygook down here. And instead, what I've replaced it with is precisely the exact same code you would have written if this was a vector. Okay? That's part of the beauty of the new C++ 11 syntax, is it unifies a lot of the same syntax for doing the same idea. Internally, it does different operations. The data is stored slightly differently. But the idea is the same, which is I have a collection of objects, just print them all out. Go through each one at a time in some order, and then print them all out one by one. That's what this syntax does. Whether you store them in a vector or a set or even a list doesn't matter. Okay, so let's just recall what this does. This prints out the elements 1, 3, 5, 7, 12, and I was playing around with it down below here, so just ignore that for a moment. So we'll just run this again. Okay, there's our 1, 3, 5, 7, 12. Okay. So now, let's suppose we want to create a set of point2D objects. Now, what the set container needs to know is it needs to know the type of object, and it also needs to be able to compare any two objects together. So if I input these 2 points, it needs to be able to tell me which one is less than, strictly less than the other one. Or not even that, it's is there a strictly less than relationship, okay? Because it's a Boolean operation. Operator less than returns true if the first argument is strictly less than the second argument. If they're equal, it returns false. Okay? So let's try and create a set of point 2Ds. So we have our set events, and that's fine. Now this is the beauty of our structured way of programming. I have my class called points.h, or my file called points.h. It contains all of my classes for point 2D, color point 2D, etc. Let's just use them. Okay, so let's create a set of point 2Ds. Call it points. That's fine. I can do that. Now if I call points.insert, let's insert a point 2D object. So let's see which one. There we go, something like this. So let's do point 2D of, say, 1, 2. And let's see, does this work? No, it doesn't work. Well, let's take a look at the error. Why doesn't this work? It doesn't work because no operator found which takes left-hand operand of type const point 2D, or there is no acceptable conversion. Binary less than. In other words, there is no less than operator defined for the point 2D class. Okay. So let's define one. Okay, so let's go to points.h. And down here, we're going to do bool operator less than. And we'll do, say, a const point 2D reference. The const point 2D reference is important for sets. Okay, so let's call it, say, P1, and then const point 2D reference P2. And let's give this a, well, let's declare it, and then we'll define it in the .cpp file. Down below, here we go. OK, now let's do the ordering that I had on your homework, just quickly, which is just comparing the radius, right? So let's just compare the radius, and then if they have the same radius, they're going to be considered equal, and so they won't be, one won't be less than the other. Okay, so only if, for example, if p1.x times p1.x plus p2 is less than p2.x times p2.x. Oh, and I need to add p2.y times p2.y. P1.y times P1.y. Okay? Return this. Now, what's the problem it's having? X and Y are private. Okay? So what's one possible solution? Make it a friend. Okay? Let's make it a friend. So go to points.h. And this is a, like I went over last time, this is a common thing to do. Before you do the public-private, declaring friendship doesn't matter where you declare it. So a lot of times they just declare friends right in the beginning, just to emphasize that it doesn't really matter. Now it compiled. It's kind of nice. OK, so now let's go back to source.cpp. And let's do points.insert point 2D 3, 4. Let's just insert a bunch. So let's do 1, 4, 12, negative 4. Let's do minus 1, minus 1. And we'll do 1, minus 2, something like this. OK, we're good. Now, let me ask you a question. How would we print out all of these elements? Yeah, let's try it, right? So for auto x in points, cout x. Will that work? Did we? Okay, maybe on your homework you did, but it looks like I haven't done it yet. So let's think about what what would I need to overload? Oh, okay, so I made a print function, but I didn't overload the output operator. So let's just do it real quick. Okay, so we std ostream reference, right? Operator less than std oh wait, I don't have you do std, right? It's just ostream. Okay, ostream out, and then const point 2d reference p. Usually we make this a friend. So let's add it to the friend. Add it to the friend zone. And then, let's see, we'll go down here and we'll define all of our, put that there. And then we'll define it in points.cpp. And what should this do? This should really just call p.print. Oh, wait, no, I didn't. OK. Where is print, actually? That's this right here. OK. I'm going to do something that you're going to understand now that I couldn't have done before. OK, watch this. So in points.h, the print function, I'm going to give it an input parameter. I'm going to call it ostream reference out. Okay? And I'm going to do something even cooler. Equals cout. Okay. I'm going to do that for all of the other print functions as well. What this is going to do, yeah, I know, I'll get there. This is going to add an input parameter to the print function, which by default is going to be cout. So if there's no input arguments, it's going to assume that it's just regular cout. Okay? So then what I can do is I can pass in this out. And now I haven't duplicated any code. And then I need to return out. Okay? I did a lot in those 15 seconds. Okay? So I took the regular print function and I added an input parameter of type ostream. And this is, again, initially when you think of the word print, you think print to the console. But I've just showed you that you can print to a file, to a file stream, etc. Okay? So we want to generalize some of these default ideas to more general print to a stream, which is an input parameter. Now, another thing which you may or may not want to utilize, it's at your peril really, is default values of parameters. You can do this. So before, whenever we called print, open close parentheses, it was written for cout, right? Now we're inputting an argument called out, and we're setting it equal to cout. And what that means is, if there's no input parameters, set out equal to cout. Okay? And then just do the regular behavior. Yeah? Can I do this with, sorry? Yes, you can do the default input parameters to any data type for any function you like. You just have to make sure that if you put a default parameter, say for the third parameter, all the parameters afterwards have to have default values as well. Because you can shorten the list of parameters, but if the fourth parameter doesn't have a default value, you can't just skip over one. So if you say you have a 5-parameter function and you put a default parameter in the third parameter, the fourth and the fifth parameter also have to have default values. So then the next natural question is, wouldn't it be better to just write 2 separate functions which are overloaded? The answer is not always. Because imagine you have a 5-parameter function. And really, you have this kind of structure where if you don't specify the last parameter, you know exactly what it should be. If you don't specify the last two, you know exactly what they should be. And rather than write 5 different functions, you just specify the default values for each one. It's much less code to write, and much less things can potentially go wrong. But that is certainly an issue. Yeah, I personally prefer the input, the default parameter values. But then, of course, we need to change the actual definitions because there, that's fine. Well, here we should, well, there, that's fine. But like here, we change this out to, or C out to just out. And then here, we change that to an out. And then here, that's fine. And everything else I think should be fine. Okay. And now it built. See that? Okay, so even though the set class, we have no control over it, we have no idea who actually implemented it, we don't know any of those things. All we did was we defined the appropriate parameters in order to interface with the set and the C++11 syntax. That's all we did. Okay? So it's along this paradigm of local reasoning. As long as my class provides certain operators defined, I can utilize the syntax. Okay, and there I have a bunch of gobbledygook printing out because the destructor is set to print out. Okay, so let's get rid of that code. Or let's comment it out. Okay. Okay. And there we go. And there's my points. Okay. So now, the next question is, how would you change the order in which the points get displayed? In other words, can you change the order for which they're, or the function for which they're being compared against each other? And the answer is yes. Okay. So if you can overload the less than operator, then you're fine. You overload the less than operator like we've done, and you can change the behavior at will. Okay, so that's the first step to realize and say, oh, I can change the behavior for a set of point2ds. Okay? So what you really should have is a operator less than accepting to const point2d references. That way it doesn't make any unnecessary copies. Okay? It'll work with just, I think it'll work with just non-const point2d references, but const is very important. Const definitely needs to be there. Okay. Here's something else. Do I want to say this right now? Okay, yeah. Here's something that's kind of interesting. If I take away, let's say I take away the less than operator. Okay, it doesn't work. Okay, it has an error because it can't compare them. But if I do this, that works just fine. That compiled just fine. Okay, so you see what happened? Even though I don't have a less than operator defined anymore, as long as I don't actually try and insert any elements into the set, it compiles and runs just fine. But it's the moment I try and actually utilize the insert function, that's when it says, wait a minute, in order to call the insert function, I need to have a less than operator defined. Okay? So in that case, we just put it back. And we're back again. Okay. Now, so that's that slide right there. Okay? So, now we have an issue. Yeah, question?
Would you mind repeating why the const is important?
Yeah, the const is important because a set, once you put an element into a set, you actually can't modify it. So you see when you input this -1, 1, for example, that gets stored as a const point2d object. what it actually does is a little complicated. But what happens is, you know, like in a vector, you could change the value of v of 0 to something else. You can't do that with a set. You can access the value of set. You can erase an element in a set. You can insert a new element into the set. But once an object is in the set, it is not modifiable. Why might that be the case?
It probably doesn't want you to like, because if you change it and then you change it to something that's already in the set, then it would have to make sure that all changes that occur doesn't make it like equal to something else in the set, and it'd be really weird.
Yeah. So the set stores the elements in a very specific manner. First of all, it stores them in order of less than to greater than. So if you change this object here to something else, it might have to rearrange its internal structure. That's very bad. If you change its value to another element that's also in the set, then it has to rearrange its internal structure. Also very bad, not ideal. So what actually happens is all of the elements get stored as const. So you can't modify them. So if you try to, let me try and change the constness of the parameters. So if we go look at points.h, if we take away the const, I'm not sure if this is going to work. I don't think this is going to work, but I could be wrong. Let's see. Oh, I have to redeclare the friendship as well. Right, the friendship is actually very much tied to the data type, and that just emphasizes that the data type, yes, cares very much as to whether or not there's a const or not a const there. Nice. Yeah, there is. OK, it doesn't work. So I have an operator less than defined. That's a good question. I have an operator less than defined, but look at the error here. It says no operator found which takes a left-hand operator of type const point 2D, or there is no acceptable conversion. Constness is a very strong property. I changed the input parameter of my operator less than to just point 2D reference, but const is really what it needs to know. It needs to know that whatever operation you apply on the elements in the set, those elements cannot change. So if you make a function which takes two point 2Ds by value, can the object itself change by calling that function? No, because whatever you pass in as the parameter, it will make a copy. So the original will always be intact. This is why I believe now we can take out the reference everywhere. Okay. Here and here. Now it compiles again. Because by calling this function, there is no chance that you can modify the internal contents of the set. That's another key difference between a set and a vector or a list. Once you input the elements in the set, they become const, and they are not modifiable. You can erase them, you can reinsert them, but once they're in there, you cannot modify them. Okay? So yeah, either those two options, either both by value or both by const reference. Excellent question. Very good question. Thank you. Now I'm going to try and put these all back. Oh no, I went too far. Okay, edit. Redo is Shift-Alt backspace. Shift-Alt backspace. Oh, that doesn't look good. Okay, let's try to recompile this. Okay, those got put back in. Let's check the class. Here I think I do the same thing. Const there, const there. Okay, now I think it should compile. Okay, now we're back to the... Okay, and it took away this one, which is out here, and then return out. Okay, that was what it took took away. And then we're back here. Okay? So, to put in the, okay, let me take out those cout statements again. Search for a tilde. And there we go. Get rid of that one. Now I search for the next one. Tilde. Do that. No, that should be fine. Okay, there are my points again. Okay, now, have you guys tried to do this in your homework? Yeah, I heard a yes. Yeah, okay. So in your homework, I just assume you're going to use a vector. But if you want to try and use a set, as long as I don't say you can't do it a certain way, any way you get it to work where it gives a correct output, that's fine. Okay? So, but here's what you'll invariably end up trying to do, which is, okay, the assignment needs to contain a collection of point2D pointers in some sorted order. So if I create a sort function for two point2D pointer types, then I put them all in a set, it'll automatically sort them for me, and I don't have to even think about implementing a sort function. Reasonable idea. Okay. It's a little tricky, though, because you cannot actually overload the less than operator for any pointer type. Okay? Pointer types already have an operator less than defined, which means that you cannot overload an operator for which a previous definition already exists. Okay? It's a little weird because point2D is a class, but point2D pointer is a pointer type, and all pointer types have the operator less than already defined for them. Okay? So that won't work. So the default definition of one pointer less than to another is it's undefined unless both pointers point to the same contiguous chunk of memory, and then it is defined as whether or not this one can be applied plus plus enough to equal this one. Don't quote me on that's the only way to define it, but I believe that's the only way in which they're defined, basically. I know that if they don't refer to the same contiguous chunk of memory, like in a vector, for example, that less than is not defined. But otherwise, I believe the definition is the number of times you would have to invoke the plus plus operator in order to get to the other one. Yeah. Or because it's a less than, it would be, can you apply the plus plus operator to get to the other one? And then if it's reversed, you cannot. You would have to do minus minus, so they're not less than. Yeah. You can also take the difference between two pointers. I don't know if you ever learned that maybe in 10a. But the difference between two pointers is it follows a similar logic. It only works when they're pointing to the same contiguous chunk of memory, and one lies before, sort of in quotes, the other one, in the sense that you can apply plus plus enough to get to it. And there the difference would be the number of times you'd have to apply plus plus in order to get to the other one. Okay, sorry, question?
Does that have like a fail function or like a fail state?
Does it have a fail state? That's a good question. I don't know. I think you just get either a runtime error or a garbage value, but I don't know off the top of my head. Yeah, question?
So the pointer comparisons would work for pointers to an array value, right? Because those are all right next to each other.
Okay, so if you're having a pointer, let's say you have an int pointer, two int pointers, and you have a vector, and those two int pointers are both pointing to elements within that vector, then yes, less than and the difference between these pointers is defined. However, if you're talking about, I believe, for example, a linked list, the standard list container, well, I'm not 100% sure on that one, but I'm pretty sure. The main idea is it needs to be a contiguous chunk of memory. That's not important right at this moment. What is important is that you cannot overload operator less than for two pointer types. It is already defined. That's the key definite answer. Okay? So how do you work around this? Well, the slides offer a workaround, but I'm going to give you a different workaround because I don't like what are called function pointers. How many students never saw function pointers in 10a? Yeah, so some of you maybe did, but most did not. I don't use function pointers. I use a different type of thing altogether, which I'm going to show you right now. So for the next set of code, ignore this. Okay, so these next two, I'm not going to work with this. This is what's called a function pointer. If I have time, maybe I'll go over it, but I want to show you guys the better way to do it. Okay, it involves operator overloading. This is why you do operator overloading first, because it unlocks a much nicer set of structure than it otherwise would. So let's say, for example, you want to store this collection of points by radius. Well, then you would overload the point2d operator less than with radius. But now let's say you want to store a different collection of points ordered solely by their x values. There's only one less than operator you can overload. That's it. You can't overload more than one. Overload it more than once with those same parameters. So what you have to do is something like the following. Either do the function pointer thing on the slides. You could look that up later if you're curious. But we're going to do something slightly different. We're going to do something that's called setting policy. So what I'm going to do is the following. I'm going to start with the idea set of point2d. And now I'm going to give it another parameter called, say, point order x. Okay? Now, what is points order x? That's just some name I made up. Okay? There's nothing special about it. Okay? So what points order x is going to be is something kind of cool. Okay? Or neat, or, well, I'll let you pass judgment. Class point order x. It's going to be a class with a single operator overloaded. The parentheses operator overloaded with, you could probably guess what's going to come next, a const point2d reference, say p1, and a const point2d reference p2. And it's going to return a bool. This is actually going to take the place of your less than operator. Okay? So that's a function. Should spell it right. Now I'm going to define it to be precisely the less than operation that I would want it to. Well, I'm just going to make it inline. Okay? With this, you would always make this. I think you would almost always make this inline. So let's do it. Okay? What do we want this to do? We want this to do something like p1.x less than p2.x. And we're going to want to return that value. Okay. Now there's a problem, right? Which is we want to access x directly. So what we can do is the following. What can we do? How can we make this work? Say it again. So you could define a function called getX. I highly recommend you do not do that because it breaks the whole reason why you have public-private variables in the first place. You really want to prevent, you don't want to have let anybody just arbitrarily access the x and the y. You can do it, but here's what I would suggest. Make this class a friend of the point2d class. Okay? So we go to points. And what we're saying here is, okay, well, add to the list of our friends, friend class point order x. Now we're fine. Okay? All right, now let's go to source. Now again, this is going to compile no matter what because we haven't inserted any elements yet, right? So as long as we haven't inserted any elements, it doesn't matter if we have the appropriate operators defined, it'll still compile. Okay? Now let's try and insert, let's insert the same set of points. Okay, so let's literally just copy and paste this without that. And we're going to replace points by x. And then this one as well. And let's add in a few more and-else. And there we have it. Okay? So let me just put this aside. Again, we inputted the same set of points in the exact same order, but we set the policy. That's what this is called. We set this, the default policy is to use the operator less than. We can only define that once. So the standard policy is go by radius. That's the bottom set of points. But then what we also said was, okay, well, by inputting as an argument not just the point2d data type, but also, what is perhaps a little bit weirder to think about is a class with the parentheses operator overloaded to be used in place of the less than operator. We can specify any type of ordering we want, any type of comparison operator we want, and store the points in that order. The reason this is so nice is what if I wanted to order the points by y? What can I do? How easy would that be? Piece of cake. Exactly. Let's do it. Okay, so we have point order x. Let's say we want to change it to point order y. We go up here. We change this. We say copy and paste to y. We change the x's to y's. We go to our points.h class. All we do is add in another friendship relation. And in 5 seconds, or maybe less, you can go to the tape to double check me on that one. Now the points are ordered by y value. Okay? That's it. Okay? Now, if you had to do everything manually, if you had to redo if you had a custom set class and you had a custom this thing and a custom this function, this would take you forever to implement. Okay? This is a very common thing that happens. You write this beautiful looking set of code, you show it to somebody, and they're like, oh, great, okay. Now the next thing you're going to do is, and then they tell you to do something which sounds so easy to do in principle, but your code base is not set up to be easily extendable. This is easily extendable. Everything is modularized, everything is separate. I didn't even touch the point2d class in terms of writing code. All I did was add a friendship relation, and I let the class point order y handle the logic behind the less than operation. Okay? That's what's called easily extendable. I can make whatever class I want now, and I can input it as a parameter to the set container. Yeah, question?
Like, why do we have to make point x, point order x and point order y a class instead of just making a non-member function? Like, can we just make point order x and point order y non-member function? Why do we have to make those classes?
You mean, do you want to do the function pointer approach, or?
No, can we just define point order x and point order y
as functions?
Yes.
Uh-huh. Yes, but then you can't use this really nice, beautiful syntax. Okay? So you see this syntax right here? Set of point2d and then point order y, or point order x. This gets replaced with that. So if you want to make it a function instead of a class, you can do it, but I hate this. I really don't like coding like this. I'll do it, it's fine, I understand it, and I have no problem with it, but I would much rather not see a bunch of pointers and weird gobbledygook syntax. That's why I'm much more a fan of, okay, while having a function as a substitute for the less than operation is more immediately kind of aesthetic, if I just sort of understand that I can define a class with one function overloaded, so all I'm doing is adding a class around the function, I can get rid of this god-awful syntax. Okay? And remember, that's part of the goal of this class as well. It's not just about getting it done, it's about getting it done in a way that just makes your code really nice and fun to read and to work with. Because at the end of the day, this is what always happens. Whenever I code up any project, I get to a point where I get stuck. Like, I'm like, ugh, and I don't want to code anymore. And if the code is ugly and it takes a long time to really figure out how things are pieced together, I just shut down and I don't want to think about it. But when the code is beautiful, it's elegant, and it's pieced together in a very modularized fashion, and I can reuse components, it's so much nicer to work with. So that's what I'm trying. You can kind of do the sloppy version on your own, but I'm trying to also indicate what I've learned from my experience as to how to structure code. So it's a fantastic question about functions instead of why. What's the trade-off with this added structure? Yeah.
So could you compare by x, y coordinate and radius in the same one, since you can only overlook the parentheses operator once?
Well, no. What you would do is you would just create a different class, comparison class, and then define whatever comparison functionality you want there.
And overload the parentheses operator again.
Yeah.
Okay.
Yeah. So don't think about trying to combine these comparison thingies. Just make a new class with a new operator, open close parentheses overloaded, and then you're good. Any more questions on this? Okay. So like I said, forget about this. See this really non-ideal syntax. You got a bunch of pointers running around. This syntax is really unideal. This iterator syntax is really non-ideal. I've showed you the new C++ 11 way of how to print out the set of all objects. Okay. Don't worry about typedef for now. Okay, so I think this is, yeah. So to summarize, here is a list of common member functions for the set function. So again, this is not part of midterm 2, but this is for the final. Okay, so these are the functions which I would have you know and have memorized. And the reason is just because I'm listing them all right here explicitly for you, and they're very intuitive. Okay, so find returns an iterator pointing to the element of the set with value A. If there is none, it returns an iterator to one after the last element, so myset.end. We will go over a bit more about how iterators work and how to work with them, I guess, next week as well. Okay, but in general, there's a max size. That one's not so important. Size is important. Empty returns whether or not it's empty. These are all very obvious. Insert and erase you're already familiar with. Clear is a good one. It just erases all elements from the set. Count, remember that function count. It returns a 0 or 1 depending on whether or not A is in the set. And then begin and end are your best friends in 10C. Not as much here because what I've showed you is the new C++ 11 way of doing things. It automatically calls these functions without forcing you to write set of point2d, comma, point order x, colon, iterator. Okay? So it hides a lot of that sort of really ugly syntax under the rug. Okay? Are there any other questions about perhaps the midterm on Friday? Yeah, so just to repeat, yeah, there's nothing on binary bit operations or overloading the bit shifting is what it's called. None of those lectures. I think it's lecture 15, 16, and it's the ones on like bits. Bits and bobs, yeah. What I thought were cute names at the time. Okay, so nothing on bit operations will be in this course. I'm nixing that topic entirely. It's also not in your book, so it's an easy thing to nix. Okay, so good question. And again, a reminder: everything up until sets, not including sets. Any other questions? Okay, so we'll start on Monday with binary search trees.